Section 5 involves writing a function rule. And we've kind of been doing this so far in this chapter, but now here it is officially for sure this time. So don't be afraid of these problems. This paragraph right here tells you, it says, this section deals entirely with writing function rules. Function rules are just a fancy way of saying equations. We're just writing equations from the information that we're given. That means we're going to be looking at probably a lot of story problems. Don't let the fact that it's a story problem scare you. I don't know who it was back when you were younger that made you think that story problems were scary. They are not. Scary problems are not story. They're not, really. You just got to learn how to do them. Once you learn how to do them, they're not that bad. But you won't learn how to do them if you just skip them every time you see them. And you're not going to have much success in this section if you just skip every single problem. So don't. Just learn how to do it, okay? I'm going to teach you how to do it. So practicing now will help you for sure for the rest of this year because story problems don't go away. If you haven't figured that out yet, you've been doing them since like the 4th grade. They do not go away. And you start to see more and more of them. So learn how to do them now so that when you get to geometry and you get to Algebra 2 and any other class that you take ever, you can do them. Not only do they help you with your math classes, but they help you basically throughout your entire life. Even later on in life when people say, oh, I never use algebra ever again. Wrong. You use the skills that you learn in algebra to solve life problems. That's part of being an adult. You're presented with problems every single day of your life. The skills that you learn in algebra help you solve those problems quickly and correctly. So first, you can estimate the temperature by counting the number of chirps of the snowy tree cricket. Anybody ever heard that before? You can count the number of chirps of a cricket. Yeah? Oh, Big Bang Theory? Okay, TV shows always steal my thunder. No, that's okay. So you can estimate the temperature by counting the number of chirps of the snowy tree cricket. Does Big Bang Theory say that it's true or false? Oh, okay. It's actually true. This is a fact. You can do that. Oh, it does? Okay. The outdoor temperature is about 40 degrees Fahrenheit, more than 1/4 the number of chirps the cricket makes in 1 minute. We want to write a function rule that represents that situation. So we need to come up with 2 variables. Always define your variables first. That's usually the part where everybody forgets. And then they start to struggle because they don't know what the heck they're doing in the first place. So what 2 things are changing here? The temperature and the number of chirps. Very good. So now I need to come up with a couple of letters to represent those variables. What's a good variable for temperature? T, sure. I'll call it capital T. Usually little t means time when we write equations. Capital T usually means temperature. And then how about number of chirps? C for chirps. Perfect. Now we have some direction. We have an idea of what it is that we're going to be writing an equation for. Otherwise, we'd just be lost probably. So it says the outdoor temperature. What is the outdoor temperature? No. What is the outdoor temperature? No. It's T. T is the temperature. It says the outdoor temperature is. Is an equal sign. Well, what is the outdoor temperature? It says that it is about 40 degrees more than 1/4 the number of chirps the cricket makes in 1 minute. So remember back in chapter 1, section 1, when we first started talking about variables, and we were writing expressions from word phrases. Where did we start? Where? Start at the variable. The variable is the number of chirps. It's sitting right here. Well, what are we doing to the number of chirps? First. What are we doing to the number of chirps first? 1/4 of the number of chirps. So that's 1/4 C. What are we doing to 1/4 C? Adding 40. 40 degrees more than 1/4 C. So I'm going to go plus 40. That's it. Okay? The key to this, though, is this step right here. figure out what it is that you're even doing in the first place. And then from that, go back to like your chapter 1 skills that we learned, chapter 2 skills that we learned, and write that function rule. That's it right there. This is the answer. There's nothing more to do. It says, what is a function rule? We got it. Could we count the number of chirps and then figure out what the temperature is? Like if the cricket chirped 100 times in 1 minute, a fourth of 100 is 25, and then 25 plus 40 is 65. So it would be like 65 degrees out. That's a lot of chirps for that poor cricket, but that would be 65 degrees. Second problem, a landfill has 50,000 tons of waste in it each month. It accumulates an average of 420 more tons of waste. What is a function rule that represents the total amount of waste after m months? What are my two variables here? They gave me one of them. Waste after what? M is the number of months. What else is changing? So we have months changing. What else is changing? The amount of what? The amount of waste. So amount, AMT, of waste. What's a good variable for that? W, sure, waste. Okay, now we have our two variables. Now that we have that, we can write the equation. It says, what is a function rule that represents the total amount of waste after m months? So I'm going to write W equals, that's my total amount of waste. Now I have to write something that has months involved. So I go back up here and I say a landfill right now has 50,000 tons of waste in it. But then each month, remember that word each or per or for every, each month, it accumulates an average of 420 more tons of waste. So what can I write? The 50,000 that's there now, yeah, for sure. Then I'm going to add waste to that. 420 M. 420 more tons per month. There's your equation. So one more time, once you have those variables, the equation kind of takes care of itself. You just got to find the right information in the problem. It's all there for you, especially in Algebra 1. Next problem. We have a concert. This is like an auditorium. You could probably picture our auditorium. Our auditorium might be this right here, and then imagine there's like a balcony or something. There actually is a balcony, but nobody sits up there. But if there was a big balcony, then all of those people would sit back here. Yeah, actually, that was really cool for the people who did that. What? Oh, yeah. I haven't seen that one. Okay, we have a concert seating plan shown below. Reserved seating is sold out. Where's reserved seating? Yeah, this right here. Reserved seating, it says, is $25 what? Per breath? Per seat. 10 rows, 12 seats per row. Well, how many seats are there in that section then? Good, there's 120 seats here. Well, if each seat costs $25, then how much money did the concert make off of the people in this section? How much? It's 120 times 25, 3,000. So there's $3,000 just off those people sitting in that section right there. Okay? It's sold out. So that's guaranteed $3,000 right there. So I haven't even read the entire problem yet, and I already have all that information figured out. Now I go back up here and I say reserved seating is sold out. Okay. Total revenue from ticket sales will depend on, look at the wording here, will depend on. We have independent variables and dependent variables. They basically just told me that the total revenue from ticket sales is the dependent variable? Will depend on the number of general seating tickets sold. That is my independent variable, okay? They specifically told it to me. So you just have to learn how to read these problems. They already told me everything I need to know. What is the, write a function rule to represent the situation. What is the maximum possible total revenue? So, we need to come up with what? What's the first thing we do in a story problem? The variables. All right, so what things are changing here? The number of general seating tickets sold is one of them. So number of general seating tickets. And then the other variable is what? The more tickets I sell, what happens? The more money you make, which is total revenue. So that is total revenue. I need two letters to represent the number of general seating tickets, and then another one to represent the total revenue. G and T, fine. Or general seating, we could call this T, and we could call this P for profit. Or we could call it R for revenue. Or we could call it X and Y. It doesn't matter. If you're not feeling creative, just go with X and Y. But you have to have this written down. I heard, what was it, G and T. So we'll call this G for general seating tickets. And then T, I'll make that a capital T for total revenue, so I don't get confused with a lowercase t for tickets. Now, in this sentence right here, it says total revenue from ticket sales depends on the number of general seating tickets sold. So I'm going to write T, the total revenue, equals, depends on. Now I got to come up with some information for the number of general seating tickets. Remember, I'm talking about money here. Revenue is money. So I have to come up with some sort of money. What is the money involved with general seating tickets? The money involved for reserve seating is $25 a ticket. We sold all the reserve seating tickets, so we got $3 grand, right? Is that part of our total revenue? Yeah. So could I write that down? What should I write? 3,000, yeah. Now am I going to sell more tickets? Probably. So is that going to add to my total of 3,000 or take away? It's going to add to, so I'm going to write plus. And now where am I selling those tickets? In the general seating. So how would I figure out how much I'm making off the general seating people? The $10 per ticket well, this would tell me how many seats I have total, right? But I don't know if I'm selling all the tickets. What? Gee, $10 per general seating ticket sold. That's the equation right there. That is, write a function rule to represent the situation we just did. But now there's something more. It says, what is the maximum possible total revenue? So they want to know, how much can I possibly make? How would I get my maximum possible total revenue in this situation? Sell every single seat. So we already sold all of these seats, and we got $3 grand. That's what that is right there. So how many seats would I have to sell here to sell out? What's that? How'd you get 480? There's 30 rows, and there's 16 seats in each row for a total of 480 seats in that section. So based on this equation, then, what should I do? What am I going to do with that 480? That goes right there. So now I have T equals the 3,000 plus 10 times 480. And I get T equals 3,000 plus $4,800. And that means T equals what? $7,800. It's a story problem, so I better include my units. Dollars. That's if they sell every single ticket. So there was kind of a lot going on in this problem, but it all starts right here with defining your variables. You got to do that. Trust me, if you start doing that now, by the time you get done with this section, and then by the time you get done with this chapter, you guys are going to be really good at story problems. So just let it happen. Next one. Kennel charges $15 a day to board dogs. Upon arrival, each dog must have a flea bath. That sounds not fun. That costs $12. Write a function rule for the total cost for n days of boarding plus a bath. And then, how much does a 10-day stay cost? So we're doing two things. We've got to come up with the equation, and then we're going to figure out how much 10 days would cost. What's the first thing we should do? Define the variables. So what are the two things that are changing here? The days, so the number of days, and then what else is changing? The total cost. So I have number of days and I have total cost. Two variables. Give me some letters. D and T. D for the total number of days, and then T for the total cost, which I'm going to use as a capital T. So now what do I write? T equals just to drop my dog off, what has to happen? You got to give the flea bath, right? How much does that flea bath cost? $12. So already I'm getting hit with that $12 and my dog hasn't even stayed. Now I'm going to add on all the cost for the dog staying. And it's how much per day? $15. So I'm going to write 15 per day. So the per tells me the variables attached to that, so it's 15D. That is the equation. It says, write a function rule, that's it. But now it says, how much does a 10-day stay cost? What am I going to do? Plug in the 10 for D. So I have T equals the $12 flea bath plus $15 per day for 10 days. T equals 12 plus 150. So I get T equals $162. Okay, that's part A. Then part B. Does a 5-day stay cost half as much as a 10-day stay? Yeah, the answer is actually no. And then we have to explain. So can you finish off can you explain that? You still have to pay for the flea bath. That's right. The flea bath costs $12 right off the bat. So that's what I'm going to say. Still have to pay $12 for the flea bath. The 5-day stay would be 15 times 5, which is 75. 75 plus 12 is 87. 162 divided by 2 is 81. So you're still not paying half as much, okay? And it's because of that flea bath that you have to get hit with right off the bat. If it wasn't for the flea bath, then would a 5-day stay cost half as much as a 10-day stay? Yeah. Next one, a little bit of geometry here. Write a function rule for the area of a rectangle whose length is 5 feet more than its width. What is the area of the rectangle when its width is 9 feet? All right, what does it say in italics? What do you think probably the most important part of what is in italics is? Draw a picture. So what kind of shape am I going to draw here? A star? Triangle? A rectangle. How do I know it's a rectangle? It says rectangle twice. So draw a rectangle. It will help. Now look for the key words. It says, write a function rule for the area of a rectangle. Well, how do I find the area of a rectangle? Length times width. So now I have A equals length times width. I'm not done. I have to put the important information into that formula. It says whose length is 5 feet more than its width. Well, what's its width? Huh? We don't know. And when we don't know something, what do? We make it a variable. So what's a good variable for the width? W. If this is W, then what's this? The length. 5 plus W, or W plus 5. It says the length is 5 feet more than its width. I don't know what its width is, so I called it W, which makes the length W plus 5. So now I can take this information and plug it in over here. Area equals, what was the length? W plus 5. So I can write W plus 5. And what was the width? W. So I have W plus 5 times W. We could use the distributive property here. You guys learned that, right? You know how to distribute? Could we distribute here? Yeah. We can go W times W. So we have A equals W times W, which is W squared plus 5W. There's our equation right there. Are we done? No, because it says, what is the area of the rectangle when its width is 9 feet? Well, look at our formula right here. We don't even have to know the length. This is all just W's. So we can go A equals 9 feet for the width. So I have 9 squared plus 5 times 9. A equals 9 squared is 81 plus 45. So A equals 126 walruses. Feet? It's feet, but it's an area, so it's feet squared. Last one. We need a function rule for the area of a triangle whose height is 4 inches more than twice the length of its base. That's a lot of words. And then what is the area of a triangle when the length of its base is 16 inches? So I'm going to draw a picture here, I think. Should I draw a picture? Yeah? Okay. What should I draw? A triangle. Do I need to draw anything special about this triangle? So it doesn't say it's a right triangle or an isosceles triangle or an equilateral triangle. So I'm just going to draw a standard, like, general looking triangle. I don't know anything about that triangle yet. Now we're going to start putting the information in. So it says whose height is 4 inches more than twice the length of its base. So I know what the height is. The height is 4 inches more than twice the length of its base. Well, what's the length of its base? Do we know the length of the base? No. It does say what is the area of the triangle when the length of its base is 16 inches, but that's like a special case. That's after we come up with the equation. Right now we don't know what the length of the base is. It could be anything, okay? So the length of the base, I don't know. What am I going to call it? O is a really bad variable. L? Okay. There's your base. Some people would choose B. Some people would choose X. It doesn't matter. We chose L. Now that I know L, we have the height. What is the height? What does that look like on my drawing? Is it this length right here? Is it this one here? How do you find the height of something? Straight up. Measure from the ground up to the top. This right here is the height. Okay? So that's the height. By the way, how do I find the area, since we're talking about area of a triangle? How do I find the area of a triangle? A equals? Yes. Well, not divided by 1/2. It's 1/2 times the length times the height, or times the base times the height. Or you could say base times height divided by 2. Okay, so here's the length. I don't know it. Here's the height. I don't know it, or actually I do know it. It's the height is 4 inches more than twice the length of the base. So if the length of the base is L, then how do I go 4 inches more than twice the length of the base? 4 plus twice the length of the base, so 2L. The height is 4 plus 2L. So I get A equals, the 1/2 sticks around, the length is the length, but the height is 4 plus 2L. So now I can simplify that down. A equals, I can distribute the 1/2 L in. 1/2 times 4 is 4/2, which reduces down to 2L. 1/2 times 2 is 2 over 2, which reduces down to 1. But then L times L is L squared. And that's your equation. It says, what is the area of the triangle when the length of its base is 16 inches? What would I do? Substitute 16 in for L. So we have A equals 2 times 16 plus 16 squared. A equals 2 times 16 is 32 plus, what's 16 squared? Luckily we have these wonderful calculators sitting in front of us that we're not just pushing buttons on constantly and breaking them. What's 16 squared? 256. So now we get A equals 32 plus 256, which is probably about 288 inches squared. The last thing it asks me to do is to graph the function rule from part 3, so we're graphing this. How do I graph a function? We did it to start class today. Make a table, yeah. X, Y. And then what? Choose some numbers. Should I just pick positive numbers this time? No. By the way, I'm not going to put Y there. I'm going to make my middle column, make a 3-column table. My function will go in the middle, 2L plus L squared. I'm going to choose some negative numbers and some positive numbers. I take -2 and I plug it in. I'm showing my work here. 2 times -2. Actually, let me undo that. When you make this table, the really nice thing about having that work in the middle is you can do some math in your head. And then when you've done some math in your head, write down what you get. So I take -2 and I plug it in right here. What is 2 times -2? 4. So I'm going to write it down. And then I have -2 squared, which is, that's 4. So I'm going to write plus 4. What's -4 plus 4? 0. So the nice thing about that middle column is it just shows your work. You can do some math in your head and write it down as you go, and that way you're not going to forget numbers and screw up. Take -1 and plug it in. What's 2 times -1? -2. And then plus -1 squared, which is -1 times -1 is +1. So I get -1. Take 0, plug it in. What do we get here? 0 plus, what do we get here? 0, which is 0. All right, take 1, plug it in. 2 times 1 is 2 plus 1, which is 3. And then take 2 and plug it in. 2 times 2 is 4 plus 2 squared is 4, which is 8. So that's the really nice thing about that middle column. It helps you show your work. Now we want to graph this. We do have some negative numbers involved. So this time I'm going to put my axes dead center. I have -2, 0. Then I have -1, -1. Then I have 0, 0. And then I have 1, 3. And then I have 2, 8. So let's answer the question. How do you know the rule is nonlinear? It doesn't make a line, yeah. Once you graph it, you can see it's not a line. There you go. Also, we'll discover, well, maybe not discover, but we'll learn pretty soon that when you have a squared variable in an equation, it makes not a line. It makes some sort of curve. It actually makes a parabola. So this graph right here is part of a parabola.